Okay, so I suggest to start. So first of all, thanks to all of you to participate to this final training workshop of the RISE-6G project. It actually has started almost 3 years ago. It's going to the end. I will briefly present to you, first of all, the overall agenda of the event, and then the key elements of the project, but then actually I will leave the floor to many of the experts of the project that will actually present our key findings and also our proof of concept results. My name is Emilio Cavestrinati. I'm the Future Wireless System Scientific Innovation Director at COLT and also the RISE-6G coordinator. And from next January, also the DESAC 6G Goals coordinator for the 2 new projects coming. I would like to thank first, before starting, also all the speakers that will speak today, but also Kyriakos and George for the excellent organization and excellent support for these online tools we're going to use. So the agenda is the following one. I will briefly introduce the RISE-6G project. Then actually there will be the Professor Alexandropoulos, George, actually, that will give a short tutorial on the key pillars and challenges around RS technologies. Then actually there will be Maurizio Crozzoli that actually will present the work issues by the work package 2 of the project. Actually, it's focused on use cases, analysis, KPIs, architecture proposal for the RS-based networks. And then actually Dr. Rafael Enrico, they will actually present the results from work package 3 that's focused on RS modeling, design, characterizations. Then Professor Paolo Di Lorenzo will present the results on work package 4 on the role of RS in enhancing the wireless communication networks. And then Benoit Denis will present the results for work package 5 on localization and mapping enable RS. And indeed, actually, Dr. Pan-Uy Dintui will present the results from work package 6. So actually it's focused on NRS for enhanced sustainability and security. Then we're going to have a break, short break. And then we will have Dr. Vincenzo Sciancalepore, which is also the technical manager of the project, will present the results from the proof of concept. And then we're going to have some specific Zoom from Shocker and from Maurizio Crozzoli again on actually on the different trials we have at the Rennes train station in France, and on the industrial premise at Fiat in Italy. And then we will have also Dr. Macera that actually will present our view in the project about innovation output, and we'll end up the workshop with a panel discussion, the road to commercialization of the RISE-6G technologies. We will moderate it again by Dr. Vincenzo Sciancalepore. I will suggest that questions you will be asked in the chat, and then we will have answers actually on our webpage. But then if there are some urgent questions at the end of the presentation, if there is some time remaining with a very short time, actually 1 or 2 questions can be accommodated, and definitely the major part of the question should be the interactive part we're going to have during the panel discussion. So about the RISE-6G consortium, we have many partners from Education, Research and Institute, as COLT, CNIT, CNRS, University of Aalborg, Chalmers, the Hellenic Republic University of Athens, and the University of Nottingham. And then we also have manufacturer, technical operators, technology providers as NEC, Orange, Telecom, and Greener Wave. And then we also have 2 important vertical industry, SNCF, which actually is a train company in France. It's actually was the center of research for Fiat. So the overall, the concept we have been promoting and demonstrating in the project actually is what we call the wireless environment as a service. So based on this new technology paradigm around recountable intelligence phases, where actually we have intentional control of the electromagnetic fields that define the propagation laws of the communication environment. Actually, by deploying and controlling in a smart way such RS, we actually modify those properties and actually control some specific parameter of the communication. As for example, we are enabling to boost performance in specific areas in terms of high connectivity by indeed making easier and more doable actually the links with the high capacity, and we can also improve the localization accuracy by means of this RS, and or improve the secrecy of the communication or the energy efficiency, or even lowering the electromagnetic field exposure to intended and or not intended users. So we consider several scenarios, and we also fix several KPIs. I would say, first of all, about the frequencies, we actually consider FR1, FR2 as bands. So the sub-6 gigahertz and the millimeter wave frequency bands. And we also consider several metrics and network-centric targets, KPIs, like in terms of latency, spatial efficiency, communication reliability, but also the accuracy in the channel estimation and the energy efficiency. And then specific to localization and tracking, we consider about localization accuracy, localization delay, localization integrity. And then one important work that will be presented on work package 6 mainly is also about the self-electromagnetic field exposure utility, and actually all related things about electromagnetic field exposure radiation and secrecy spatial efficiency. As a reference scenarios, we consider, I would say, 3 main typologies. So scenarios and use cases where we have enhanced connectivity and reliability, enhances localization and sensing, and enhances sustainability and security scenarios. And here on the bottom of the slide, you see 5 key prototypes of RS we did in the project at different frequency bands, ordered from the left, from lower frequency, on the right to higher frequency. So covering from 5.2 gigahertz to 145 gigahertz of bands. So we have set 4 challenges to this project. The first challenge is the definition of novel architecture compared multiple RS. And actually, this will be presented by Maurizio in a few minutes, actually. And then you will see what we did in this domain. Then for the challenge number 2, the characterization of fundamental limits of RS network in terms of connectivity, localization, sensing, and sustainability have been a work, I would say, across work between most all the technical work packages. And you will see not only some hints about what we did in terms of algorithms and theoretical studies, but also how those will be applied and actually have a positive impact on the proof of concept we actually delivered. Then, as a third challenge, actually, we define innovative estimation algorithms, control mechanisms, and protocols to enable to trade all these different parameters thanks to the dynamic programmable wireless propagation environment. So this is very important here, because actually we not only consider on paper possibility, but we also consider drawbacks and limitation due, for example, to the control that actually is causing a lot of limitation to the impact of these technologies. And then as a third challenge, actually, was the design, the development, and engineering of trials based on RS. And we actually, and you will have more details later, we have 2 full trials. One on extreme coverage enhancement at the rain train station, where, interesting, we also have this indoor-outdoor different context of work. And actually in the field trial number 2, the accurate indoor localization for continuous broadband connectivity with AGV at the Fiat premise. I would like to thank your attention. I don't want to jeopardize more the time, and I will let the room for the next speaker.